for the theory, for all the specific like theory, calculation, and so on, then you can watch chapter 6 and chapter 7. And food engineering in Vietnamese, I already post. You watch chapter 6 and chapter 7, and you can review all the background about drying. Okay. Chapter 6 is about humid air, and then chapter 7 drying. So here we go quite fast. Why should we do drying? So when we apply this, we remove water. We remove water means we will reduce water activity. Then we reduce growth or the activities of microorganism. We reduce the rates of enzymatical reaction, chemical reactions. So we reduce the microbial changes, biochemical changes, chemical changes. Means that the shell life would be extended, right? So the first objective of drying is to extend the shell life. Example, if you have fresh beef, then you have to put in a fridge and you store for several weeks maximum. Okay, but if you have dry beef, then you can store at room temperature. After proper packaging, you can store at room temperature, and then the sell life can be up to 9 months, for example, because dry. The water availability is very low for these changes. When we do drying, of course, we reduce the mass and we reduce the volume of the products. Means that we reduce the cost for transportation and for storage. Normally, drying will make harder textures of the products, and then some aroma components also develop during a long drying process, and then this will improve sensorial quality. So generally, drying will extend the sell life, will reduce the cost of transportation and storage, will improve sensorial quality, will diversify products for the market, for the demands of the consumers. Okay, we just review a little bit the theory. This is an illustration of the textures of the food. And if we use air, when we use air to dry, we move the air along the surface of the food, and then water on the surface first will evaporate. After that, the water from the inside the food will migrate to the surface and then will also evaporate. Evaporates means conversion from liquid water into vapor and then taken up by the air. And the food get drier and drier. So the water can evaporate on the surface, but can be also evaporate somewhere here, okay, and then migrate outside. If we look at the pattern of moisture content during drying, when you move, you go along with drying. Then, if you look at the moisture content, this from A to B is called actually initial period. We will see in a while. And from B to C, this is like linear, quite abstract. Okay, linear means, and then here, if you look, when it's linear, mean after the same period of time, the same amount of moisture is removed. And then after that, the reduction from C to D, the reduction in moisture content is not linear anymore, but becomes slower and slower. Means that after the same period of time, less and less amount of moisture is removed. Here, more or less, the evaporation of free water on the surface. And here, the water from the structure inside will migrate out. And then the rate of the migration is lower than the rate of evaporation. That's why the evaporation become less and less. So now we look at this graph so we can understand the drying process better. This graph indicate the heat and the mass transfer during drying. So here this axis represent drying time, and here we have the pressure and temperature. So in the previous slide we already said that we already mentioned that drying normally occur through two periods, two stages, constant rate and falling rate. Normally there's a short period, which is called initial period before the two, but normally this very short, so we can ignore during explaining this drying process. During constant rate period of drying, the amount of water removed from the food per time is constant, mean after the same period of time, the same amount of water is evaporated or removed from the food. During falling rate period, the amount of water evaporated from the food become lower and lower after the same period of time. And because during this falling period, the water now become more and more bound to the food, so it's not evaporated easily. So it takes more time for the evaporation to occur. Now we look. This line represents the dry bulb temperature of the drying air of the air, and this line represents the water vapor pressure in the drying air. This is like relative humidity of the air. So these two lines represent the drying air. So we have two other lines. This one is the temperature of the food, and this curve is the vapor pressure of the food. This is also more or less like water activity of the food. Vapor pressure of food indicates how easy the water can evaporate into vapor and then give a pressure. So during constant rate periods, the vapor pressure of food is constant because this water is now free. Okay, and then after that, during the falling rate periods, the vapor pressure of food is reducing. The water become bound more strongly to the food components, and then which is more difficult to evaporate, which means that also lower water activity. You can look back chapter 5. There we also discuss the definition and how to determine water activity of food. So during drying, we see this is the heat transfer. The heat transfer, and this is the mass transfer. The vapor or the water from the food evaporate into vapor and then is taken up by the air. The temperature of food will increase to the temperature of the drying air. During constant rate periods, the temperature of the food doesn't increase but stay at a constant value, and this is a wet bulb temperature of the air. Now water is free to evaporate, and we already know that evaporation uptake energy, then it will give the cooling effect, and then the food will not increase in temperature because water evaporates freely, which cool down the food. We can explain it that way. Okay, and here water also still freeze. This is why the vapor pressure is still the same height. Now, so drying take place for these two differences we call two driving forces: the difference between relative humidity of the air, vapor pressure of the food, and the other one, temperature of the air, temperature of the food. When these two differences are larger, then the rate of drying is faster, right? So first thing we can look at is that normally the constant drying period is shorter. The constant rate drying normally takes shorter time than the falling rate drying. The falling rate drying is to evaporate bought water, so it takes longer time. And then the second observation that we should pay attention is that the temperature of the food only increases to approach the temperature of the air during the falling rate period. And because the temperature of the food increases, because the falling rate drying takes longer time, so the sensorial quality and the nutritional value of the food are more impacted or more influenced during the falling rate drying. And then the third point, now we look at the these two driving force. The first one is a difference in temperature. The second one is a difference in vapor pressure between the food and the air, the drying air, so relative humidity of the air and water activity of the food. So to do drying, we need these two driving force. This difference is even more important. If this is equal to 0, we no difference and no evaporation at all, right? Like it's up to here already. Or for example, when the air is already saturated, for example, the relative humidity of the air is here. If the relative humidity of the air is here, more or less like 100% is already saturated, it cannot take the vapor from the food anymore. Okay, so to do drying, we lower the relative humidity of the air. We increase the temperature of the air. These two things we do. Why increase temperature is better for drying or drying take faster? Because when you increase the temperature, then actually at the same time you reduce the relative humidity of the air, and also we increase the temperature, then we increase the motion of water. We reduce the viscosity of the food, we increase the mobility of water, so water evaporate out of the food more easily. This is the reason why normally for drying, in the past for the conventional methods, we increase the temperature to dry. Okay, so now I explain why increasing temperature will reduce relative humidity. If we already discussed in chapter 6 the Vietnamese course, so we know that this curve represents for relative humidity of the air. So relative humidity here 100%, for example, 90%, 80%, 70%. While on the vertical axis, this one represents for the absolute humidity of the air. Absolute humidity means the gram of water per kilogram of dry air. Okay, how many gram of water there is in the dry air? That's absolute humidity. One absolute humidity value can have different relative humidity depending on the difference in the temperature. This one is the dry bulb temperature of the air. So here you have T4 higher than T3, 2 and T1 here. Okay, so when we increase the temperature of the air, it's actually we reduce the relative humidity. Even the same amount of water still there present in the air. Yes, and when we reduce the relative humidity, when you reduce this line, then you can dry faster. So now, just to remember, when we do drying, there are two simultaneous processes which take place, the heat transfer and the mass transfer, and we need both the processes to occur at the same time to have drying.